Hello my dear students, welcome to this video lecture. This lecture is for the 4th semester Diploma in Engineering, Mechanical Production RSC and Plastic Streams at Aligarh Muslim University, Aligarh. The course code is BME 404 and the course title is Machine Drawing 2. And my name is Syed Imran Shafi. So today we will be talking about cam profiles. If we have a look at our syllabus, so we have cam profiles for the following cases: profile of disc cam with knife edge followers and their displacement diagrams, profile of cam with roller followers, and profile of cam for offset roller followers with displacement diagrams. So basically we need to draw the displacement diagrams and the cam followers and the cam profiles for the different types of followers and cams. So before going to draw the cam profile and the displacement diagram, it's always better to know some of the basics of cams and followers. First of all, what is a cam? A cam is a mechanical member used to impart desired motion to a follower by direct contact. As you can see in this figure, there is a cam and this is a cam, the blue one, and the light blue one is a follower. When the power is in this shaft, it rotates the cam, and the cam, it transfers the power to, or it imparts the motion to the follower. So in a cam mechanism, a driver member is known as cam because it is driving, and the driven member is known as follower. There are various examples we will discuss in this video later, or where cam and followers are used. There are different types of arrangements in our course. Basically there is radial or disc cam. In radial cams, the follower reciprocates or oscillates in the direction perpendicular to the cam axis. So the follower, it oscillates in the direction perpendicular to the cam axis. So this is the basic definition of radial or disc cam. There are various types of followers. As we have already mentioned, follower is an element to which the motion of cam is provided. It is driven by the cam. There are different classifications and different types of followers. For example, there is a knife edge follower. The example is like that. There is only a point of contact on the surface of the cam. Then there is the drawback is because there is a very small area of contact, there is a lot of wear and tear. Then there is a roller follower. The example is like that. There is a roller which rolls on the cam, and then there is flat face follower. This is the flat face follower, and then there is spherical follower. So in order to have better understanding about cam and follower mechanism, I am going to show you a small video clip. The source is given here. So let's watch. Cam and follower must be clear now. And now we can move on to drawing the displacement diagram and the cam profile. We also need to know some of the nomenclatures that are used for drawing cam profile and the displacement diagram. For example, what is a cam profile? What is base circle? It is the shortest radius from the cam center to any part of the cam. Trace point, pitch curve, prime circle, pressure angle, pitch point, pitch circle, and stroke. You can study from any book, or you can consult this slide for the better understandings of the nomenclature, and you can relate with the given figure so that things are much more clear. Now we should come to a problem. The problem is draw a cam profile to operate a knife edge follower using following data. Outstroke is 120 degree with simple harmonic motion. The outstroke dwell is 60%. Return stroke is 120 degree with uniform velocity. The dwell for the remaining period of the cam, lift of the follower is 30 mm, and the least or the minimum radius of the cam is 5 centimeter, and the cam rotates in clockwise direction. So as we know that there are basically three motions or the three phases in which a cam rotates. First is the upward stroke or outstroke. Then there is a dwell period where it is neither rising nor it is falling, and then there is a return or fall. And for and for the upward stroke or the outstroke or the return stroke or fall, it can follow different types of motions. For example, in the figure given, the outstroke is for 120 degree with simple harmonic motion. The motion is simple harmonic, and the return or the fall is 120 degree with uniform velocity. So we need to keep this in mind while drawing displacement diagram. So this is a final displacement diagram that I have shown. I will show each step in the coming slides, but to have understanding about what a displacement diagram looks like, I have shown in this slide the final displacement diagram. So I will explain first what is this displacement diagram signifies, and then we will move on to step by step construction of this displacement diagram. So as we know, we have chosen a scale. On the x-axis we have chosen 1 centimeter is equal to 1 centimeter is equal to 20 degree of cam rotation. On the x-axis 1 centimeter signifies 20 degree of cam rotation, and on the y-axis 1 centimeter signifies 1 centimeter of the lift of the follower. So as given in the problem, there is an outstroke of 120 and 1 centimeter is equal to 20. So 120 will be 6 centimeters. So this portion signifies the outward stroke. It is 120 degree and it comes out to
so
be
I
6
hope
centimeters.
after watching this video,
Then there is a dual period of
concept
60 degrees. So 60 degrees. So it will be 3 centimeter on this scale, and it will signify dual for 60 degrees. And then there is a fall or return of 120 degree, another 6 centimeter. So this is how we have chosen a scale. And since the upward stroke is simple harmonic, so we have drawn a semicircle here, and I will tell you what this semicircle will do in the figure. And the fall is uniform velocity. So now we'll move to step-by-step construction of this one, this displacement diagram. So what I have already told, that we have chosen a scale, and in that we have chosen the upstream for 120 degree as 6 centimeters. 1 centimeter is equal to 20 degree. Then there is a period of 60 degree, we know it is given as dual period. This is 3 centimeters, and another 120 degree or 6 centimeters as fall or return. So what we have done, we have drawn 6 centimeter of upstrokes, and then we have divided this 6 into 6 centimeters or 120 degree into 6 equal parts, 1 2 3 4 5 6. And then what we have done, we have drawn this semicircle, because this is a simple harmonic motion. The upstroke is following simple harmonic motion. So we have divided this semicircle into 6 equal parts. And what we have done, and we have drawn horizontal lines from these points. As you can see in the figure, we have drawn these horizontal lines. And what we have done, where these horizontal lines are cutting these vertical lines, we have marked points. For example, first point is this one, second point is this one, third point is this one, fourth is this, fifth is sixth, and so on. And we have drawn this with a smooth curve. So this signifies the upward stroke for 120 degree. Then there is dual. In this period, the cam is neither rising nor it is falling. It is somewhat in same position. and then there is a uniform velocity, so it will be shown with a straight line. So finally, this is how a displacement diagram is drawn. Now we have to draw a cam profile. To draw a cam profile, what we will do, we will make two center lines, and the point where it intersects is the center of our cam, and we will draw first the least diameter of the cam, which is given as 5 centimeter. After that, what we will do, as it is given, as we have already discussed, it is given that rise upward stroke is 120 degree. So we have marked 120 degree here, and we have divided this 120 degree into equal parts. So 1, 2, 3, 4, 5 and 6. So 6 equal parts. We have drawn this out stroke. And then it is given that for another 60 degree it is dual. It is neither rising nor it is falling. So 60 degree there is dual. And for another 120 degree it is falling or return stroke. So we have divided this 120 also in 6 equal parts. 1, 2, 3, 4, 5, 6. After that, what we have to do, we have to mark points like this. For example, this is we have to calculate this distance, and we have to mark here. For example, this point comes here, and this distance, whatever is this distance, we will mark from this least circle to the point we have, the angle that we have marked. Again, this distance we have marked here, this distance we have marked here, and so on. So we have marked 6 points on the 6 angles that we have marked, and then we have joined these points with a smooth curve. Then we know that there is a dual period, so there will be no this will be a straight arc. There will be no either rise or fall. And similarly, like we have done in the outward stroke, we will do in the return stroke also. We will mark these points. For example, this is point here, this distance is this one, this distance is this one, and similarly we will mark these points and we will join with a smooth curve. Here I have shown with the green color. So the red color shows the upward motion, blue color shows the dual, and the green shows the return stroke. So in this way we can draw a cam profile. So this is a cam profile and this is the displacement diagram. So in this way we can draw cam profile and displacement diagram. Now we can have various arrangements, like we have different types of motions for the follower, different types of followers. So we will discuss these different problems in coming videos. Thank you very much for watching this one.